Okay, so number one here, we have to think 2 to what power is equal to 16. 2 to the fourth is set. 3 to the what power is 1. Anything to the 0 power is 1, right? Okay, part C, 10 to the what power is equal to 0.1, or 1/10. This would be the -1, which would be E. 2 to the what power is equal to, so it would be 2 to the what power is equal to the square root of 2. I'll write all these out here. 2 to the what power is equal to 16. That would be 3 to the what power is equal to 1. 10 to the what power is equal to 1/10, or 0.1. Okay, and this would be 2 to the 1/2, right? So 1/2 was choice B. This would be E to the what power is equal to e to the -2, right? So we got -2, which is choice F. Okay, and F, we have the same, it's the same thing as 1/2 to the what power is equal to 8. If we, it's going to be negative to get it up top there, right? And then 2 to the third is 8, right? So it would be -3, choice D. Okay, so number 3, here we want to write this in log form. So I think this is the base raised to the outside part equals the inside part, is what I think in my head. So the base raised to the outside part equals the inside part. Okay, and I know that, yeah, so this, you just have to rewrite it. That's all we have to do. Okay, so this one here, base raised to the outside part equals the inside part. Number 7, so log base 10, we can just say log. You can put the base 10 there, but you don't need it. Of the outside part equals the inside part. Okay, and then here, if with E we use natural log, okay, instead of log. So it'd be better to put natural log, because that means base E of 1 is equal to 0. Another way you could say this is it's log base E of 1 equals 0. But usually instead of this, that's not the proper way to do it. The proper way is to say natural log. So log base E is the same as the natural log. Okay, for number 11, we want to write this in exponential form then. Okay, so we think base raised to the outside part equals the inside part. So 6 squared is equal to 36. Okay, base raised to the outside part equals the inside part. Number 15, base, they give you base 10, you wouldn't have to say that, the 10 there, but 10 raised to the -3 is equal to 0.001. And remember, if there's nothing here, it's like a base 10, right? Okay, so this would be 10 raised to the 0.5 is equal to the square root of 10. So 1/2 power is the same as square root. For the next couple, we want to solve for x. So we can think base raised to the outside part equals the inside part. Okay, and then we did these the other day to solve these in 5.2. We get the same bases. So this is the same as 5 to the third power. So we know that x has to equal 3. Okay, so here base raised to the outside part equals the inside part. So if I think here, what to the 24th power will equal 3 to the 12th, I know that this number here has to be a base of 3. And what exponent, what do I do with it? Multiply, right? So if I take half of 24, that's equal to 12, right? So x is going to equal 3 to the 1/2, or the square root of 3 if you want to write it as a square root. Okay, number 23, base raised to the outside part equals the inside part. And I know that 6 to the, so that's a -3. And I know 6 to the -3 is 1 over 6 to the third, which 6 to the third is 2/16. So 1 over 2/16. Number 25, base raised to the outside part equals the inside part. Okay, and This, I kind of think of it as this. Remember, this is the cubed root of x to the fourth. So what can I take the cubed root of and raise it to the fourth power to give you 16, okay? So you can kind of think that you could also go through and multiply, like if I cube both sides and then take it to the fourth root of it, you could do that as well. Or let's do this. Let's actually solve it out mathematically. Take the fourth root. So I have the cubed root of x is equal to 2. And if I cube both sides, I get x equals 8. Or if I would have cube both sides first and then take the fourth root of both sides, I get 8 as well. Number 27, base raised to the outside part is equal to the inside part. Way I would think about this is 1 over 1,000. So the negative kind of brings it down, and I know that if x equals 10, right? Or you can also think about this. There's different ways you could solve it. You just kind of think 10 to the negative third is going to equal this. You could also if you want to actually work this out, you could say this is 1 over x to the third is equal to 1 over 10 over 1,000. So I could say that x to the third is equal to 1,000, and I could take the cubed root of both sides, and I get x equals 10. So there's different ways you can think it through. Okay, this one here, this is a 9. So I know that 9 raised to the outside part is equal to this. Okay. Let's see, what do we do with this one? I had to pause the video and think about this one. This one was a little harder. I got it now though. Okay, so if I get them both to be both base 3s, so this would be 3 squared, right? So 3 to the 2x. Okay, this side, if I rewrite this is the same thing as fourth root of 3 to the third power. Okay, 3 to the third is 27. And if I take the fourth root, would be 1/4. So that's the same as the 3 to the third to the 1/4 power, which is the same as 3 to the 3/4. Okay, and this is like 1. So I want to remember, when you have the same bases, when you divide, you subtract. So this is the same as 3 to the negative 1/4. Okay, now I got the same bases. So now I can say that 2x is equal to negative 1/4, and divide by 2, I get negative 1/8. Number 45, it just says to put it in your calculator. Scientific calculators have log and natural log without the bases. If you're using a TI calculator, it has the log right here and the natural log right there. If you want to put something, I'll just show you this real quick. If you want to put something other than that, if you hit math and go all the way to the bottom, you can say log base. This is something that they've added since I've taught, and you can put a different base in there. But for the most part, this particular question, just log and natural log. And it's under your function miscellaneous in Desmos. So the log of 53, decimal approximation, if I go to like 3 decimal places, 1.633, and 48 be like negative 1.854 if you round it to the third one. Natural log of 43 would be like e, right? Okay, be 3.761, and 54. The natural log of this is negative 4.269. Okay, so that's just a matter of typing it into Desmos and making sure you get that there. Okay, with number 57, they want to know if this concentrate of a grapefruit, they give us that number, we want to know what the pH of that grapefruit is. So the pH of the grapefruit is equal to negative of the log of this concentrate of a grapefruit is 6.3 times 10 to the negative 4. And you can use your calculator to work this out, and it comes up to be 3.2. So it is acidic. Okay, and number 16, lye or sodium hydroxide. You put it on gardens sometimes. Our pH for that would be negative log of 3.2 times 10 to the negative 14. Put this in your calculator, and we have a pH of 13.5, which is alkaline. Okay, it's got a, so a lot of times if your soil in a garden is too acidic, you put lime in there to bring the acid down. 63 gives us that beer has a pH of 4.8, so it's alkaline. Sorry, it's acidic. So we have 4.8 is equal to negative log of what we're trying to find here, this concentration. So to solve this, I'm going to divide by negative 1. So negative 4.8 is equal to just a regular log of this. It'd be easier to put an x there, but anyway. Okay, so I'm going to change this to an exponent. Remember, just regular log is log base 10. So 10 to the outside is equal to this number right here. So if I work this out, the concentration of beer, 10 to that power would be about 1.6 times 10 to the negative 5. Okay, 66 says that suppose we have $2,500 invested in an account that continuously compounded. Find the time that it would take for the account to grow to, in this case, $3,500 at 4.25%. Okay, so using this equation here, we want to know, we put in $2,500. That's our initial amount, our principal. And our rate, we said, was 4.25, so 0.0425. And we want to solve for the t. Okay, so the first thing I would do is divide by the 2,500. So 3,500 divided by 2,500 gives me 1.4 is equal to e to the 0.0425t. If I take the natural log of both sides, so natural log of 1.4 is equal to, natural log cancels this out, the e, so just get 0.0425t. So then my t is equal to the natural log of 1.4 divided by 0.0425. And if you use your calculator or your Desmos and you work that out there, what does it come up to be? It comes to be about 7.9 years. Okay.